Twice in 7 hours, the sun fired the most violent shots it had taken in nearly 3 months. Twice, radio signals across half the planet went dark. And if forecasters are right, the worst part of this event hasn't even reached Earth yet. Buried in the alerts NOAA pushed out this week is a single number that should concern anyone who owns a phone, drives a car, or trusts the power grid to keep the lights on. We'll come back to that number, because what just happened on the sun is not a routine story. Late on April 23rd, solar physicist Ryan French was watching the western edge of the sun, a volatile sunspot region called AR 4419 had been crackling for hours. Then, at 9:07 p.m. Eastern Time, his monitors lit up, an X24 flare, the strongest eruption the sun had thrown at us in 78 days. 7 hours later, before sunrise, it happened again, an X25, even stronger. 2 X-class flares from the same sunspot in less than a single night. That alone is rare. But it is what came with them, something scientists call a sympathetic flare that has researchers asking a question they cannot yet answer. Could the sun be coordinating these eruptions? And if it is, what happens next? Here is what an X-class flare actually is. Solar flares are ranked on a logarithmic scale. A, B, C, M, and X. Each letter is 10 times more powerful than the one before it. C-class flares happen constantly. M-class flares can disturb radio, but X-class sits at the top of the chart. There is no Y. The scale just stops there. Picture a billion hydrogen bombs detonating at the same instant on a single patch of the sun's surface. The radiation travels at the speed of light. 8 minutes after the flare erupts, it slams into Earth's upper atmosphere, whether anyone on the ground is ready or not. That is exactly what happened on April 24th. The first flare hit the day side of Earth and ionized the lower atmosphere across the Pacific Ocean and Australia. Pilots on long-haul flights suddenly lost their high-frequency radios. Maritime operators expecting routine check-ins heard nothing but silence. Emergency services that depend on shortwave were cut off from the rest of the world for the better part of an hour. Then it happened again. The second flare blanked out East Asia. Same mechanism, different continent. And here is the part that matters. Those blackouts were not a glitch. They were the sun telling us, in the only language it speaks, that it is not finished. Now remember the open loop from the start, the number you should worry about. Here it is. The Type 2 radio burst that accompanied the second flare clocked in at 1,869 kilometers per second. That is the speed of the coronal mass ejection that came with it. A vast cloud of magnetized plasma ripped off the surface of the sun, now hurtling through space. It is moving toward us, mostly. The sunspot that produced these flares is sitting on the western edge of the sun, which means the bulk of the eruption was thrown off to the side rather than aimed directly at Earth. Forecasters at the Space Weather Prediction Center say the main mass of the CME will probably miss us. Probably. But they are also watching for what they call a glancing blow, a sideswipe of the same plasma cloud, expected to arrive on April 26th. That is tomorrow. If it hits harder than predicted, we are looking at a G1 geomagnetic storm, auroras as far south as the northern United States. Minor satellite disturbances, the kind of event that would have been a once-a-year story a decade ago, but which now feels like it happens every few weeks. So why does it feel like every few weeks? Because the sun is not behaving like the sun we grew up with. We are deep inside solar cycle 25, and this cycle has surprised everyone. NASA and NOAA quietly admitted in late 2024 that the sun had entered solar maximum, the peak of its 11-year activity cycle. Sunspot numbers blew past every prediction. Some months produced more X-class flares than entire previous cycles. And here is the part that keeps space weather researchers up at night. Solar maximum does not end cleanly. The most powerful eruptions in the last cycle did not come during the peak. They came 2 and 3 years after, on the way down. Which means the worst of this cycle may not be behind us. It may still be ahead. That brings us to a report you almost certainly missed. In January, the United Kingdom's Science and Technology Facilities Council quietly published the 4th edition of a document with one of the dullest titles in modern science. Summary of Space Weather Worst Case Environments. 80 pages, almost no media coverage. What is inside it should be on the front page of every newspaper. The report walks through what would happen if a single solar storm, not a once-in-a-million-years event, just a once-in-100-years event, actually hit the modern world directly. We have had one of those before. It was 1859, the Carrington event. Telegraph operators were electrocuted at their desks. Sparks jumped from telegraph keys and set paper on fire. Auroras were seen as far south as Cuba. The damage was almost philosophical, because there were so few electrical systems to break. Now imagine that same storm hitting today. Power transformers the size of small houses would overheat and fail. The kind of transformers that take 18 months to manufacture and replace. Satellites in low Earth orbit would lose attitude control and start tumbling out of formation. GPS would degrade or vanish entirely for hours, possibly days. The internet, yes, the internet, would suffer cascading failures because the long undersea cables and the satellites that route around them depend on a stable magnetic environment we usually take for granted. That is the technical damage. The British report does not stop there. The most haunting section is not about machines, it is about us. The report explicitly warns that during a worst-case event, the human response could make the disaster worse than the storm itself. Panic buying empties shelves before authorities can issue real warnings. Public unrest follows when people stop trusting the messages they are getting. Misinformation moves faster than the science. Authorities lose control of the narrative within hours. Let that sink in. The scientists writing this report are not primarily worried about the sun. They are worried about what we will do when the sun finally does what it has always done. So picture this. You wake up on a Tuesday morning. Your phone will not connect. Your car's GPS is frozen. The lights flicker, then go dark. Your bank's website is down because the data center it routes through has lost its uplink. Gas pumps stop working because gas pumps are computers now. Your neighborhood loses water pressure within hours because municipal pumps run on the same grid that just collapsed. How long do you have mentally before your routine breaks? That is the scenario the British scientists are trying to plan for. And the only reason the twin flares of April 24th did not trigger something closer to that nightmare is geometry. The sunspot was on the wrong side of the sun. Pure luck. The next sunspot might not be. Here is what is happening right now. AR 4419 is rotating away from Earth. It will soon disappear around the western limb, but it is not gone forever. The sun's rotation will bring it back into view in roughly 2 weeks on the eastern side, pointed straight at us. And if that region remains as volatile as it has been for the last 72 hours, we will be looking down the barrel of an angry, magnetized sunspot with a proven track record of firing X-class flares. That is not a forecast. That is just orbital mechanics. The forecasters are watching. NOAA's Space Weather Prediction Center has raised the probability of further X-class flares to between 10 and 15% over the next 3 days. That sounds low until you remember that the average for any given week is closer to 2%, and the M-class probability is already over 50. So what does this mean for you? It means the next time your phone shows you a notification about northern lights appearing in unexpected places, do not dismiss it as a pretty distraction. It is a tell. Auroras at unusually low latitudes mean charged particles are reaching deep into our atmosphere. The mechanism that paints the sky is the same mechanism that, if amplified, kills the grid. The sun has been quiet for the last 170 years in the geologic sense. Modern civilization grew up during one of the calmest stretches of solar activity in recorded history. We built everything we depend on under the assumption that the sun would keep being polite. Twice in 7 hours, on April 23rd and April 24th, the sun reminded us that politeness was never part of the deal. So here is what I want to know from you. If you got 72 hours of warning before a Carrington-level storm, what is the first thing you would do? Not the panicked first thing, the smart first thing. Drop it in the comments. I read every one of them, and the answers people give to this question say more about us than any scientific report ever could. The universe reminds us, on its own schedule, that we are still very small.